Hello, in this video, we will introduce quicksort. Quicksort works as follows. You have a list and you choose a pivot. Use the pivot to divide the list into two parts. So the list 1 and list 2. Everything before the pivot is now less than or equal to the list, and everything in list 2 is greater than pivot. So the pivot divides the list into these two parts. So this is called a partition. We're going to perform this operation, partition. After this, pivot is in the right place. So now you can recursively apply quicksort on list 1 and list 2. The algorithm can be described as follows. Quicksort the list. This is the array size. If the array size is greater than 1, so we're going to select a pivot. Use this pivot to partition the list into list 1 and list 2, such that all the elements in list 1 is less than or equal to the pivot, and all the elements in list 2 is greater than pivot. Then apply quicksort on list 1 and on list 2 recursively. So for simplicity, we're going to select the first element as the pivot. So look, this is the list. Here is 5. Now 5 is here. After the partition, everything before 5 is less than 5. Everything after 5 is greater than 5. So 5 is in the right position. Then you can continue to partition. In the first one, apply quicksort recursively. So this is for the first one. And so this is 4 here. So for the partition, and results in the empty part in this list 2. So now this, for this, is 0 is right here, and everything before 0 is less than or equal to 0. So this is an empty list. And D, so this, look, this is 2 is put right here. So you can see this is the process. We go with, look at the first one now and look at the second one. So this is all. So we're going to write the quicksort for the list, and the size is here, array size. And so we use the help function, and for this, we have this is the list, and this is the first, and this is the last one is array size -1. So the index, so we're looking at the index and performing this partition, get the pivot index, and now you're going to apply quicksort on the first and pivot index -1, and here is pivot index +1 last. So let's see how we do partition. This is how we do partition, is to have this low and high for the index. Here is, this is the pivot, and this is the right after pivot is low, and the last one is high. So we're going to compare this low with the pivot here. And so this is in place, 2 is fine, but we move to the next one here, and you're going to see this is stop here because 9 is now greater than 5. So then we go to the other end for high. So high, so this is go all the way for high is right here. So 7, 6, they're greater than 5, and this is 1 is less than 5. So now we swap 1 with 9. And after that, so this is 1 here, 9 is here. So we continue to move high to the right and to the left and low to the right. So here's the animation, low and high. So here's the pivot. So now you can see this is.
Since list row is less than equals pivot, low was moved forward. Since list high is greater than pivot, high was moved backward.
So now they stop here and you do a swap.
86 was swapped with 23. Since list row is less than equals pivot, low was moved forward. Since list row is less than equals pivot, low was moved forward.
Stop here.
Since list row is less than equals pivot, low was moved forward.
Now for high.
Since list high is greater than pivot, high was moved backward.
And now swap.
78 was swapped with 7.
So this is the process until low is after high. So eventually, as you continue, so let's do continue now.
Since list row is less than equals pivot, low was moved forward. Since list high is greater than pivot, high was moved backward.
So continue, move high.
Since list high is greater than pivot, high was moved backward.
Continue, move high.
Since list high is greater than pivot, high was moved backward.
Stop here.
Since list high is greater than pivot, high was moved backward.
Swap.
31 was swapped with 6.
Continue.
Since list row is less than equals pivot,
Stop here.
low was moved forward. Since list high is greater than pivot, high was moved backward.
Now swap.
52 was swapped with 20. Since list row is less than equals pivot,
So
low
now
was moved forward.
they're close here.
Since list high is greater than equals pivot, move high backward.
So now is this the low is now greater than high. So it means you have searched everything. And so you can now swap the element that pivot with the low here.
The pivot 24 was swapped with 20. The partition is completed. Click reset to start over.
So this is the one. Swap this element that pivot with the element that high. So this is for partition, and here is the implementation for this partition. So you're doing partition for this, and this is the low and high. So this is the low and high. So this is the low goes moving to the right, and high and moves to the left. So this one is high minus minus, and then you perform the swap. So this is after this is all done. So that is here you are going to swap this pivot with the element at high. What is time complexity for quicksort? And let's look at time complexity for quicksort. In the worst case, the pivot divides the array each time into one big subarray with the other array empty. So in this case, you're going to see the time complexity in the worst case is still out of n squared. In the best case, the pivot divides the array each time into two parts evenly. So this is here is Tn, and then so there's two parts evenly, and partition time is out of n. So the overall time is out of n log n. But the worst case and the best case are not representative. In this case for quicksort, we can analyze it mathematically to prove that the average time is out of n log n. So this is a pretty good algorithm, is quicksort. One better thing about the quicksort is so-called in-place sort. So all you need is just one array, the original array. You don't need the temporary array. As for the merge, you need the temporary memory. So when you merge two sublists into a new list, you have to have a new memory for that. So that is the difference between the two. So they're very similar, but look at the quicksort is you have the pivot, use the pivot to partition the list. For the merge sort, no, you just divide it two parts and apply the merge sort. And then after this two sublists are sorted, then you merge it. So that's for the merge sort. And for the quicksort is the pivot. Use the pivot to partition the list into two parts. And then the two parts are sorted recursively using quicksort. So that is all for this video on quicksort. See you on the next video.